We're on 5.2, graphing systems of inequalities. I am going to skip down to this second example. So these are in slope-intercept form, and these are inequalities. That means they have a less than or a greater than. That means we're going to have to shade and show the entire solution set that's in the shaded area. So the first one, we're going to start at 3, then we're going to go up 2 over 1. Now we need to decide, is this a dashed line or a solid? This one has a line under it. So we're going to draw a solid line. I missed a little bit. And then less than means I'm going to shade right here. So then I'm going to do this one in a different color so you can see it better. Now this one starts at 1, and then it's a negative slope. This negative in front of the x means negative 1 over 1. So, whoops, I missed. Down 1 over 1, down 1 over 1. Is it dashed or solid? I know there's a way I can get a dashed line here. Is it dashed or solid? It is dashed. I can't figure it out right now, so I'm just going to do that. It's also less than. Now, the solution set to this system, that means these two together, is the double shaded area. So let's look and see what got double shaded. It would be right here. It has a solid line boundary on this side, a dashed line boundary on this side, all the points in the double shaded region. So remember, it goes on forever. All the points in this double shaded area are what we call solutions. That means if you plug them in, they'd make it both true. So is 0, 0 a solution? Well, it's right there. If I'd drawn my line correctly, yes, it would be in the double shaded area. Is negative 2 negative 1? Yes, it's in the double shaded area. What about 2, 7? It's on the line, but it's not anywhere near the double shaded area, so no. I also want to show you what happens if you plug these in. So let's substitute 0 for both x and y. In the first one, I would have 0 is less than or equal to 2 times 0 plus 3. 0 is less than or equal to 3. Yes, that's right. So let's try that with the second one. 0 is less than negative 0 plus 1. So that's 0 less than 1. Yes. So if you can't tell from the graph or you don't have the graph, you can just plug in. Let's do that for this one that was a no. Let's see what happens. Y is 7 is less than or equal to 2 times x is 2 plus 3. 7 less than or equal to 7. Yes, that's true. But let's try the second equation. 7 is less than negative 2 plus 1. 7 is less than negative 1. No, that is not true. So that's why this one was a no. It did not make both equations true. Let's look at, let's look at the one on the top of the next page. So this one is not solved for y. So the first thing we need to do, get rid of the x. Now we need to divide by the 2. And the thing you need to remember is there's an imaginary 1 there. So I have y is less than negative 1/2 x plus 3. So start at 3, go down 1 over 2, or up 1 into the left 2. This does not have a line under it, so it is a dashed line. It's a less than. Where did all the y's get less as we go down? So we shade below. And then this one, I need to take away the 3x. Negative y is less than negative 3x plus 4. Now, this is where we get tricky. We have to divide by negative 1 to get rid of that negative. Now, when you divide by a negative, it flips this. So now I have 3x minus 4. I'm going to put my point on negative 4. I'm going to go up 3 over 1. It's still dashed. Now it's greater. So where do the y's get greater than this line? Well, where y goes up. So what's my double shaded area? Right in here. It's a little triangle here. But both lines are dashed. So let's look at this. Is 0, 3 a solution? It is on the dashed line. So no, if you aren't sure, plug it in and see if it makes those true. Is 0, 0? Yes, it is in the double shaded area. What about 2, 2? That's the point of intersection of the lines, but they're both dashed. Now, if we weren't sure, let's plug in right here. 2 times 2 plus 2 is less than 6. That's 6. 6 is not less than 6. What would happen here? 3 times 2 minus 2 is less than 4. That would say 4 is less than 4. So if there were an or equal to under it, it would be a solid line, it would be a solution. But since it's on dashed lines, then no, not a solution.